In this question, it is given that if beta is equal to limit of this as x tends to 0, then the value of 6 beta is. Clearly, beta is equal to limit x tends to 0 e to the power x cube minus 1 minus x cube whole to the power 1 by 3 plus 1 minus x square whole to the power 1 by 2 minus 1 into sin x upon x cube into sin x by x whole square. I have multiplied divide by x square because the limit of this part is clearly 1. Hence, I will be writing limit x tends 0 e to the power x cube minus 1 minus x cube whole to the power 1 by 3 plus 1 minus x square whole to the power 1 by 2 minus 1 into sin x whole upon x cube. Because the limit of this part is 1, therefore into 1 is there. But note that we are allowed to take the limit of a part of the question only if that part is in multiplication or division with remaining whole question on which limit is operating, and limit of that part should be non-zero finite also. And because this part is in multiplication or division with remaining whole question on which limit is operating, and limit of this part is non-zero finite also, therefore I am allowed to take the limit of this part and it is 1. Obviously, if I am able to divide the question into two parts, that is one part this, second part this, and the part this upon this will be easier for me to deal, because in the first part everywhere x cube will be there and my calculation will become easy if I take x cube as t, and in second part this upon this will be there. That is, I will be writing limit x tends 0 e to the power x cube minus 1 minus x cube whole to the power 1 by 3 upon x cube plus limit x tends 0 1 minus x square whole to the power 1 by 2 minus 1 upon x cube into sin x. Note that separating a limit into two parts is not always allowed. Only in one case it is not allowed, and that case is in the form of infinity minus infinity. Suppose the limit of this part is infinity and limit of this part is minus infinity. In that case, coming from here to here will not be allowed. Or suppose by chance the limit of this part is minus infinity, limit of this part is infinity, again it is of the form infinity minus infinity. In that case, separating the limit into two parts will not be allowed. Otherwise, it will be always allowed. Hence, I have separated, and if by chance after calculation I find that the answer is coming to be minus infinity plus infinity or infinity minus infinity, then I will have to rub all these and I will come back to this, and I will have to take such a direction that this should not come, because this direction is making my solution very simple. Therefore, I have separated. If by chance finally I get the answer infinity minus infinity, I'll be rubbing all this. But usually it doesn't happen, therefore it is good enough. And for this part, let x cube equal to t. This becomes limit t tends 0 e to the power t minus 1 minus t whole to the power 1 by 3 upon t plus limit x tends 0 1 minus x square whole to the power 1 by 2 minus 1 upon x square into sin x by x. Again, in next step, I'm allowed to take the limit of this part because this part is in multiplication with remaining whole part on which limit is operating, and in next step I will take the limit of this part as 1, and taking the limit of this part will be allowed to me because as I told you just now, taking the limit of a part of the question is allowed only if the limit of that part is non-zero finite and that part is in multiplication or division with remaining whole question on which limit is operating. As this is in multiplication with this, therefore I am allowed to take the limit of this part. And because it is in 0 by 0 form, we are allowed to use L'Hopital's rule here. I get e power t minus 1 by 3 1 minus t to the power minus 2 by 3 into minus 1 upon 1 plus limit of this part is 1, and I'm allowed to take the limit of this part because this is in multiplication with remaining whole question on which limit is operating. And in the remaining part, everywhere x square is present, therefore for x square I write y. It becomes limit y tends to 0, 1 minus y to the power 1 by 2 minus 1 upon y. And this is equal to, as t tends to 0, this tends to 1. And here it gives 1 by 3. Therefore, I get 1 plus 1 by 3. And in this part, again use L'Hopital's rule plus, and because it is in 0 by 0 form, we are allowed to use L'Hopital's rule here also. I get 1 by 2 1 minus y to the power minus 1 by 2 into minus 1 upon 1. Limit y tends 0, 1 by 2 1 minus y to the power minus 1 by 2 into minus 1 upon 1. That is, I get 1 plus 1 by 3 minus 1 by 2, that is 5 by 6.